what is Flexalon? So Flexalon is a 3D layout system, 3D first layout system for Unity. The first of its kind as far as I know. And so the idea behind Flexalon is asking the question, okay, why is layout limited to 2D platforms like the web? And while in 3D, we're stuck placing things manually or writing scripts every time we want to arrange objects in some sort of predictable pattern. And there are other plugins on the store to help you with things like 3D layouts of a simple grid, or placing objects in a stack, but they're not holistic. They don't create a system where these layouts can be nested, have all sorts of interesting relationships between their sizes. If you have a circle of objects and you want that circle to adapt to the size of the objects within the circle, that's usually not something you see. So that's Flexalon is in a nutshell. It's like taking the inspiration of what's available in 2D layout and applying it to 3D layout. So throughout this, we're going to talk about, what are the core principles behind Flexalon, and then talk a little bit about what are the basic layouts, animation capabilities, interaction capabilities in Flexalon, and then I'll show some live demos of things I've already built in the past, but then show a little bit behind the hood of how they've been built, and then take a peek under the hood on how you might build custom layouts, how you might build custom adapters to really extend how Flexalon is used in your project. So let's start with the design goals. Let's see if I can shift this over and draw a few of the design goals for Flexalon. First, I wanted it to be 3D first. It's fairly easy to go from 3D to 2D, but it's really hard to go the other way around. And so you see, I could have adapted a open source framework like Yoga from Facebook, which does Flexbox really well, but it's done in 2D, and extending it to do 3D would be really difficult. So 3D first, big pillar of Flexalon. Let's do here, design principles. The second big one is I wanted it to be all C#, but still performant. And this is important because when you have something in C# in Unity, it's much easier to edit. It's much easier to do performance profiling over it. It's much easier to have it work on all platforms. So I wanted to keep it all in C#, but I also wanted it to be performant. And performant in this case means, since everything's compiled to IL to CVP anyway, performant, what really it means is, can we make sure that the layouts are not running when they don't need to be running? In 2D, typically you only need to rerun layout if the screen size changes, the browser size changes, and I wanted the same principles kind of to apply here. Only if you change the layout properties on your layouts, it will only mark dirty and update those parts of the layout that are necessary. The next one here is for to make it extensible. So I didn't want a framework that just does flexible layout, just does grid layout. I wanted a system that could handle all sorts of different types of layouts. So extensibility, and we can see this in the shipping version of it. There are 8 different layouts that all kind of coexist, and they can all be nested within one another. And then another one here is kind of related. We want nested layouts, and it's impossible to build any sort of UI without nested layouts. It's also useful in 3D to have nested layouts. And then finally, just as a bonus, I wanted to make sure that it could be easy to do animations and interactions using this framework. It wasn't getting in the way, at least, but then even better if it has a few built-in capabilities for how you can create simple animations like you might do in CSS, transitions between layout positions, and then simple click and drag interactions. So that's the basics of Flexalon, the design goals behind it. And then within Flexalon, we have the 8 different layouts that it comes pre-built with. These are easiest to show off on the website. There's this list here, which shows all 8 of them. The grid layout for positioning objects in a grid. Flexible layout stacks objects one after the other. The circle layout, this video picture seems wrong, but the circle layout is put an object in a circle, but it's actually very powerful in the sense that it can also create spirals, also create staircases, either from the center out or from the bottom going up. You have the curve layout, which lets you define any arbitrary Bezier curve and lay out objects along that curve with all sorts of interesting options for how you might repeat that curve, bounce that curve back and forth, those kinds of things. And then the shape layout is kind of inspired by those games that you sometimes see on mobile where you have a crowd of people running, and they're usually in some sort of formation shape. It could be a circle, but often I see them in like a hexagonal shape or a square shape or triangle shape. And so this is positioning a bunch of characters in one of those shapes with X number of sides. The random layout is then I just want things to be in random positions. And so this layout gives you, it's interesting because it's random, but it's predictably random. And you can easily change the random seed, and you can see how random is it, how much distance do I want to give in the x-axis, how much size variance do I want to give it. And then there's constraints. So constraints are kind of the inverse of a layout, where instead of in a parent layout positioning its children, which is the typical case, in a constraint case, the child positions itself relative to a parent. And so this gives you kind of that extra layer of flexibility where you might already have a layout somewhere, but you just want to attach something onto the end of it, or you want it to follow another layout without it being part of that layout. And then we've got interactable. Well, that's not the last layout. The layout that's missing from this list is the align layout, which is a relatively simple layout, but it's kind of important nonetheless, where you can position all objects along the same aligned plane. So you could say, and this is easy to see in the templates. So this one here, where you want to just position some objects on a surface, and importantly, you want those objects to line up with each other. And it can also be a corner, it could also be an edge. So it's not positioning multiple objects relative to each other, but it's positioning all the objects relative to some sort of surface or edge. So that covers the basics of the different layouts. Then we have animations. And for animations, it's easy to show this page that talks a little bit about, we have different ways for basically to say if you change a property on the layout, then the objects will animate smoothly from their current position to where they need to be to fit in that layout. And so the curve animator here it's showing is whenever I'm swapping the position of the object that is getting dragged, the other objects are moving to fill in, to fix their positions. And the curve animator works by defining this curve. I can show this in Unity actually. So if I create a flexible layout, let's just stick some cubes in here. And so if I add the curve layout to these, so sorry, the curve animator, then I can define this curve. And what this does is say, okay, the object is going to start at some position, you don't know exactly where, and it's going to end up at its layout position. What kind of curve should its path take in terms of the rate of change? And so if you say, I want something like this, it's going to start off going very quickly and then slow down towards the end. Similarly here, it's going to start off slowly and then speed up as it gets closer to its target position. And this will kind of give you the sine effect of you start off slow, you go fast, and then you slow down when you reach the end. And if you wanted to, I've gotten this question a couple times, if you want it to go, if you want the whole animation to be faster or slower, you can say, how long should this entire thing take? And you can see at the bottom, there is a timeline and saying it's going to take up a total of 1 second. So you can change this and say, I want it to actually take, I'm holding down shift to keep it on the 1 at the top. And you can see that it can go down to, say, a third of a second or so. And then when I play, and if I swap the positions of the objects, then you can see that they animate smoothly into place. So similar to the curve animator, we've got this lerp animator. And the difference is really that, well, the implementation is different. So the way the lerp animator works is that it is constantly chasing the end position by interpolating from its current position to some fraction from its current position to its final position. And so it might say every time I'm going to move 10% closer to my final position. You can get this effect of it's always kind of starting quickly as it, you know, that 10% is a large chunk of the space, and then it's slowing down when it reaches the end. And the real benefit of using this animator instead of the curve animator is that you get these, you can see here, I'm constantly changing the target position, and the objects are smoothly moving towards that target position because all the lerp animator is doing is saying 10%, 10%, 10%. If I use the curve animator here, then every time I change that target position, it's going to recompute the curve from the start. And so it's always going to start the curve over, and you'll see the objects are moving very slowly, or whatever is at the very beginning of your curve, until the target stops, and it can finish that curve. So you have different use cases for lerp animator if your target's constantly changing, and curve animator if you want a different sort of curve, but your target is not constantly changing. And then finally, you've got this fun rigid body animator, which is useful. And I'm going to have a cool demo to show how to set this up, where the objects are moving towards their target positions using physics forces that come from the rigid body animator. So it's constantly using, I think it's called add force function on the rigid body to say, always push the object towards its target layout position. And I'll talk a little bit about this, but you can also animate the layouts themselves using standard Unity animators. I'll show an example of how to do that, where maybe you want to animate things along a curve, you want the circle to rotate. You can just animate the properties on the layouts themselves to create these interesting effects. So that's the basics. I guess let's get into a few interesting demos. Well, there is one more basics I wanted to cover. So if we look at this, an important piece of Flexalon is the ability not just to, so in this case, what's happening is if you look at this component, it's called Flexalon object. And Flexalon object controls how does the size of this object or this layout get computed, and how does it interact with other objects or other layouts that it might be inside. And so in this case, this is the Flexalon object for the flexible layout. And you can see that the size is set to layout, which is the default if you create a layout. And what that means is it's going to take the objects that are inside it and try to compute an automatic value for its size. If I add more objects, then the size is going to increase. But I don't always want that. So maybe I want instead to say it has a size that I specify. And so this is going to determine how big it's going to be in a parent layout. So if I created another flexible layout and I put this inside of it, let's say I duplicate it, now you can see that these two flexible layouts are next to each other in their parent based on their own size. So if I increase this size, I am increasing the size of one of the flexible layouts. So let me delete these for a minute. So why might this be useful if you just have one layout and some objects in it? Well, you can also size the objects inside to fit within the layout. And there's kind of two interesting ways to do that. One way, so these cubes don't have any Flexalon components on them. If I give them a Flexalon object component, now you can see how Flexalon is computing the size of each one. And right now it's based on the size of the mesh of the cube. And that's what this component value means for the size. So there's 4 options. Component means compute it from one of these components. It's automatically determined unless you write your own adapter. Layout means take it from the child layout. And fixed means specify a specific value. But what if I want it to fit within the parent layout? So there's 2 ways to do that. One is to say I want it to fill all the available space in my parent layout. So if I assign these to fill, you can see now that as I change the size of my layout, the objects grow and shrink to fit within that layout. The other way to do this is you can leave it as component, and instead you're saying, I don't really care if the layout is too big, but if it's too small, I want to shrink the objects inside. And the way to accomplish that is to go to the minimum value and say that it can be something other than its current value. So if I say the minimum of these cubes, let's say they can be 0.1 in the width, then as I shrink this flexible layout, specify the wrong object, it's cubes. I specify the min to be 0.1. Then if I shrink this flexible layout, if I grow it, nothing happens. But if I shrink it, the objects should shrink. Something's missing. Okay, well, demo failed. I'll have to debug why that's happening. But we'll see this again in the UI example, where where you oh, there it goes. Not sure why. Oh, it's because of my gap. So if I set my gap to 0 here, you can see the objects shrink as soon as I make the layout too small for them to fit in. Okay, so let's show some demos. So I'm going to start with the carousel. So this is a little example of a carousel that you might build. So you're just a simple circle layout, and when I click the arrow, okay, so the idea is that if you change the carousels, if you change the start at degrees of the circle, the carousel can rotate, and it's supposed to be responding to my inputs as well. I'm not sure why that's not working. But the idea is to change this value whenever the user presses a button. And then let's see how this is built really quick. So I'm going to disable this one and just kind of build it from scratch to show you how it works. So if I created a simple, let's go back to our scene, circle layout. And then I can change the radius of that circle however I like and drop a few planes into it. So if I go to 3D object, oops. Let's do quads. So quads are going to be our images. And I'll just drop a few of these in. And you can see here that they're kind of spaced out at a fixed step. So it's saying every 30 degrees, I'm going to space a new one out. That's not what I want in this case because I want a carousel. So I want them to be spaced out evenly. So now they are at even points around the circle. And then I want them, so we can see here, camera's not perfect, but we can see here they're all facing me, which is not really what I want for the carousel. I want them all to be facing out of the circle. So let's change the rotate option to out or in, depends on the type of object you have. So now all these objects are rotated this way. So if I work my way around the circle, I can see that they're all facing out. If I want then to rotate those objects around the circle, I would change this start at degrees property. So you can see easily how you might, in a script, say when a user presses the left arrow button, I'm going to rotate it so many degrees to in the negative direction or the positive direction. Okay, so another interesting aspect of this original carousel, there's two kind of interesting things I want to point out. So one is you can see these objects are correctly sized to fit the image. They're not just squares. So we're going to see how to do that. And the other interesting aspect of it is if I take my carousel and I wanted to adjust all these objects, you can notice that they're all the same height, even though they are different dimensions. And so if I increase or decrease the size of my circle in the height, the objects are fitting in that circle. So how does that work? So let's start by making all the objects, let's give them some images and make those images sized correctly. And how does that work? So I think this is, okay, so here's an example. I want this image. And at the moment, let's add a few more of these. So at the moment, this bird is kind of stretchy. And so the way Flexalon typically works is if you have a mesh, it's just using the size of that mesh to compute the size of this object. And so the size of the quad mesh is a 1x1 square, and so it's just going to use that. So what we would need in this case is to use a custom adapter. We want an adapter that says, take the texture size applied to this mesh and resize the mesh to fit, or resize the Flexalon object to fit the size of that texture, depending on one of the dimensions, the width or the height, and keep the aspect ratio. So fortunately, the samples comes with this adapter already that you can check out. Now there was a bug I noticed when I was prepping for this demo in that adapter. So send me a message if you want the fix for it. But with the fix adapter now, oops, now it's huge. So the reason it's huge is because now it's saying, what is the texture pixel size of this bird? And applying that to the Flexalon object, which isn't really what we want because that's really big. You can see here, it thinks it needs to be 1365 by 2048. That's the size of the image. So what we want is to constrain one of the ends. We want either the width or the height to be fixed, and then we allow the other axis to freely adjust based on the adapter. So let's go ahead and add a Flexalon object to this mesh, and we're going to set the, let's, as an example, set the width to be fixed. So now the width is definitely 1 because that's what I fixed it to. And the height is determined by the component, which is determined by this image adapter that we added. So now as I change the width, it maintains its aspect ratio. But that's not actually what we wanted, because if you remember in the original, it was based on the height of the circle. So instead of setting this to fixed, we're going to set it back to component and set the height to fill the height of the circle. So now when I change the height of the circle, let's change it from layout, which is computing based on the other children, which are size 1. Let's change it to fixed. Sorry, not the depth, the height. And as I change the height, you can see now this image is changing in height as well. And we could go ahead and do that for all the other quads. Let's do this one, and for all of them, then add the image adapter and the Flexalon object. Doesn't like me editing the one that already exists. Okay, we can set all of their heights to fill. There you go. So now as I rotate this, you can see they all maintain the same height and their aspect ratios get fixed. I'll dive a little bit deeper into how the image adapter works if you're interested in writing your own adapter. But for now, let's move on to the next demo. So for this next one, I want to go over a bit of physics because that's always just fun to look at. Where's my seats? So this is a demo I made pretty early on. I was kind of copying something that was made in Cinema 4D. I thought it would be cool if Flexalon could give you some of the same visual effects capabilities that Cinema 4D can do. And so basically what you have here is a bunch of objects that are kind of in some sort of position, and they are being disturbed by this glassy object in the middle. And after the disturbance goes away, when the object moves away, they kind of go back to where they're supposed to be. So how does that work? Let's break it down. So let's start with this glass ball. It's very simple. It's just a sphere collider, and it's got this script on it that's going to move it back and forth. That's really all there is to the sphere, to the ball. Then we've got this flexible layout that contains all of the balls. And so let's remove all the fanciness from this thing and see what we get. So let's start by going to the flexible layout. Let's disable these extra components. You have to remove it. And you can see this is just the flexible layout that's laying things out in a line, stacking objects one after the other. And if I increase the gap, you can kind of see them a little bit better. But I want the objects to overlap a bit, so that's why I reduced the gap to a negative number, because that gives me a more interesting effect. Then I want to modify their positions. And there's two scripts here that help with that. First, there is this, this script is not in the package. I'm happy to share it, but I didn't think it was quite up to quality to include it in the package. But all it does is it modifies some property on all the children. In this case, I'm modifying the width randomly before doing anything. So when I enable that, you can see now their widths are random. Then I could also use that same component to modify their positions, but instead I wanted to use the Flexalon random modifier, which is included in the package, which you can then use to say, I want to modify after the layout finishes, after they've all been placed in this line, I want to modify something about their position and their rotation. So in this case, I want them to move up and away. So I'm going to modify their Y and Z axes. let's say from -1 to 1. And you can see they're kind of all spaced out. But I want to be more squished than this, so I'm going to go back to the flexible layout, reduce the gap a bit more, and that's it. Now, if you just did this, that's very nice, but the ball, the glass ball wouldn't interact with the children. And so how do I do that? So if you go to any one of these children, you'll see, for one, they have a rigid body and a sphere collider. And if that's all they had, then you'd get something like this. Let's remove this. You can see that the glass ball is pushing them away and they're kind of flying off into the distance until it no longer is touching them. And so the effect that we want is that they kind of almost magnetically get pulled back into their layout positions that they started off with. And so that's where the Flexalon rigid body animator comes in. That's that third animator that I talked about at the beginning. And if I add this component, increase the position force a little bit, it's going to, every frame, add, I think, 10 units of force to the objects and 5 units of rotational force to the objects to push them towards their correct positions. So now you get something like this again. This does take a little bit of fiddling around with to get it right. And the reason is because all this is doing is applying a force. If you just apply a force, the objects will just fly past their final layout positions and kind of bounce back and forth. And so what you really want them is to kind of slow down when they get closer. And so you want to add some sort of drag. You can see there's a drag on the rigid bodies, there's an angular drag, and then you want to mess around with the material on the collider to add some friction as they move past each other so that they roll and not just bounce like, because typically a sphere doesn't roll when it hits, a perfect sphere does not roll when it hits other objects. So if you want them to roll around, you need to add some sort of friction so that when they touch each other, they kind of roll around each other. Add some bounciness, so you have to mess with these values a little bit to get the feeling to be whatever you want it to be. But the core of it is, if you want the objects to move back to their original positions using forces, use the Flexalon rigid body animator. Okay, let's see. The next demo I wanted to go over. Okay, so the next demo I wanted to go over is a curve layout demo. And then the last one we'll do is a UI demo. So curve layout. So I have this somewhere. Okay, so an example of a curve layout animating here is this hello world. Let's go into the curve layout. So the idea behind a curve layout is you define some points using and those points and tangents create a Bezier curve, which you can read up on if you're interested. And then you position objects along that curve, and it has some interesting options to how to deal with the tangents and then how to deal with the ends of the curve. And so one of my favorite demos that I made is, let's find it. This one. So in this demo, you have these birds kind of flying, and they're flying in a particular path, and you can see that they are going around in different patterns. So here you have them going over in this curve and then repeating the curve by inverting the curve. In this case, you just have them going in a line, and then they go in the curve, and then they extend out in another line. I want to show how this demo works. And you can also see, so let's see, so I have this here set up, and here's the curve. So here's our curve, And what's going to happen is you have, in this case, these balls instead of the birds. They're going to follow this curve in some way. And we can see the curve layout here. These are the points on the curve. So if I move this thing, you can see the value changing in the tangent, because this is one of the tangent points. So when you're creating these curves, you want to check these boxes as needed, because there's a lot of little handles and you don't know what's what. And I haven't found a good way in Unity to create these kinds of 3D movement handles and indicate them in a better way. But if I, for example, lock the tangents, then I can move the curve points around. So I can move this end around, and you can see how the curve adjusts when I move it. I can move this one around. And let's move our objects into the curve. So this start at property determines where the objects are along the curve, where the first object is along the curve. So right now it's at some negative value, but if I change it to 0, you can see it starts at the very beginning of the curve and starts working its way around the curve. As I increase this number, the first object is moving, which is also moving the rest of the objects along the curve. I can mess with how far apart the objects are by changing the spacing value, increasing and decreasing that. And then I can change, I can also say, it's just like the circle layout, I can say I want them to be evenly spaced. So now the first object is at the beginning of the curve, and the last object is at the end of the curve, even spaces between them. Sometimes you want to create some sort of interesting shape or something, so you want to connect the start and end point of the curve, and that's when you would use this evenly connected property, where it's still evenly spaced, but it doesn't put an object at the last spot so that you can connect it back to the beginning. So I can move this now. I can move this here, and it's still, now it looks like it's all connected in some sort of circuit. And you don't have to have tangents on these. You could make these all corners, which would make it into some sort of shape. So you can make a star, you can make a square, whatever you want. Okay, so let's go back. And so even though these changed back, let's just reopen the scene, undo my changes. So then the final interesting properties are, well, there's rotation, which is not going to do anything to these spheres because they look the same from all angles. But the rotation options are similar to the circle, where you can say they are pointing into the curve, they're going along the curve. One of the fun things that I had a lot of trouble getting the math right for is if you have something like a bird and it's going along the curve, as you can see here, if it's going up at some point, if you go along this curve, it's going to need to go upside down. So that was a fun little thing to solve. How do you make sure that that happens correctly when things are going along the curve? Anyway, so the reason they're not doing it in this demo is because it was a little harder to see the repeating when things were going upside down. So the before start and after end properties determine what happens when you go before the start point of the curve or after this end point of the curve. And so in this case, I'm just having it repeat on both ends. So as I change the start position, you can see it's just repeating the curve as if there was another curve connected that looked exactly the same. And it can just repeat forever and ever and ever. Another option for it is to stop. So you can say, I'm going to go along this curve till I reach this point, and then the object will just stop at that final point. This is useful if, for example, this point is off screen. Let's say this is the only part of the curve you care about. You can have the objects animate or show up on this part of the curve, and then they just stop when they reach that end. Ping pong is means once you've reached the end of the curve, ping pong back in the other direction. So this is particularly useful if you just have one object, let's say a slider or something, and you want it to go back and forth along the slider. You can have it ping pong once it reaches the end, things like that. And then there is extend as a line. You can say keep going forever and ever and ever, just like that. And you can have, we did repeat and then repeat mirror. So what's this going to do is say, imagine there was another curve connected to this curve that looked just like this curve, but was inverted. So every point is at an opposite point, and every tangent is going in the opposite direction. So now you get it curving in the other way. So that is the curve layout. Okay, let's do the last demo. Let's talk a bit about UI. So initially, Flexalon was only capable of doing 3D things like this. And the reason is because there are other UI frameworks on the asset store. I didn't feel the need to encroach on their territory. But then I had the idea of doing Flexalon Copilot as a generative AI solution for UI. And then I thought, well, the built-in tools for doing layouts are not giving me what I need to do in terms of positioning UI layouts. And so I need to bring Flexalon to the 2D space so that it can work properly in UI. And that also involved adding a few features to Flexalon, such as this min-max support that were needed, but that's generally needed by 2D layouts. That isn't super important for 3D. So let's take a look at how this layout works. We're going to just rebuild it from scratch. It won't take very long. So this UI was generated by Copilot, and let's see. This entire thing is actually generated by AI. So outside of Copilot, I went to Stable Diffusion and generated this background. That took a little while to clean up. I generated this image based on almost its exact same description. And then I generated these icons. And then I used Copilot to put it all together in the video, which you might have seen. But if you haven't, you can go and check it out at flexalon.com/AI. So how does this all work? It's basically, in this case, just a bunch of flexible layouts. You have a piece of text at the top. You have a panel surrounding the whole thing. It has a flexible layout top to bottom. It's got the title, then this image, then this paragraph, then this rewards text, and then these two. These two are also put into a flexible layout. Each one inside of that has its own flexible layout, so it's flexible layouts all the way down. So let's try to recreate this. Start off with a canvas that we're starting from scratch. And we're going to create a panel just like this one. So that's just a flexible layout in the negative Y direction. And we're going to give that an image for the background. Then we have, I'm going to use the same image that I had for this one, which I think is this one. And it's important to say that let's increase the size so you can actually see what it looks like. And move it over to the right. Okay, so this is what it looks like in the scene. Let's anchor it to the right. Okay. This is why I prefer to use Copilot for these things, because I can never figure out the right numbers to put in. Okay, can we see it? Not yet. There it is. Okay. So I think that's because the canvas is drawing order in the hierarchy, I think. No, I'm wrong. There's a way to control the order of the drawing, and this one was getting drawn behind. Okay, so now it has some sort of size. You can see it's all squished together. And it's important when you create a back panel to set the image type to sliced. And I had to go in and with the sprite editor make sure it was sliced so that these corners are always visible and don't get stretched with the scale. And so now if I increase the size of my flexible layout, you can see that we have this nice little panel where we can start dropping things in. Once we have a few items, we can change the height to layout so that it just fits the objects within it. So let's add inside of here our title. Let's see if we can show this guy. Yeah. So let's go ahead and add the title, which is going to be Text Mesh Pro. Go into UI, Text Mesh Pro. Type something in. And you can see it's white. That's no good. So we're going to use the color picker to pick the same color as, let's say, this. And change the size up a bit. And now it's in the middle here because flexible layout by default places everything in the center. So we can change the vertical alignment on the flexible layout. And it's a little confusing because in Unity, Y goes in the up direction. And so we actually have to align it to the end of the Y-axis. And so now it's at the very top here. So how do we prevent that? We don't want to count these borders as part of the layout. So we can add a padding to the flexible layout to make sure nothing is put along those borders. And so in the Flexalon object, there's a padding field. You can change, let's say, the top here to 20. Let's increase it a little more. Put it somewhere about there. So that's about 85. And we can make sure the bottom is also 85. And then the left and right, they look okay right now because everything is centered. But once we have this image, we might need to increase the padding on the left and right. So let's add the image. To do that, UI image. And you can see that now the flexible layout is placing things left to right. That's the default. You'll actually want it to go in the direction of the negative y-axis. Again, Unity Y is up. And so now we have title and then image. Drag this image into the sprite. And we want this image to fill up the width of the whole panel. So we can add a Flexalon object to that and have the width fill the panel. And you can see it's stretched. And the reason it's stretched because by default, Unity doesn't check this preserve aspect ratio checkbox on the image. These are all things Copilot takes care of for you. Okay, so now you can see we do need to add that padding to the flexible layout. So on the left, we're going to add 20. Oh, sorry, not margin padding. And to the right, okay, we need more than 20. Let's keep adding some. There you go. So now it looks pretty good. We do have this kind of really close gap between the title and the image, so we can add a bit of a gap to the flexible layout. And that'll add the same gap to everything else that we put underneath. Okay, so next we need some more text. We can actually copy the text from the other one because I don't want to retype it. You can see Copilot added a few more layers here. In the case that you wanted to add more things like an icon next to this text, it's kind of adding different sections and then adding the text under those sections. So we don't need them just for this demo. So we're just going to grab the text directly, drop it into the flexible layout, and there we have it. Very easy. And then we're going to add another piece of text for the rewards. Make that bold. Okay, so, and center line that. So, okay, we have a problem here, which is that the text is starting to fall off of the canvas, and so off of the panel. So we want to change the height of our panel to adapt to the size of its children. So change it from fixed back to layout, and there we have it. Now we want these two boxes. So those are just images with a color on them. But they're arranged horizontally. So we need to create a new flexible layout just for them. Flexalon, flexible layout in the X direction. So that's all correct. And then underneath that, create two images next to each other. We're going to give them the same color as this thing. Oops. There we go. And we want, you can see they have sharp corners. In Unity, the way to change the corner radius is to choose a different sprite. So we can choose the UI sprite, which has slightly rounded corners and a little bit of margin on the edge. And then we can space these out. And in this case, I want them to take up the whole width. And so we can say the gap type is space between, and this flexible layout should take up the whole width. Probably a better way to do this actually is to say I want to specify the size of this gap between them, and then I want the objects to fill in the rest of the space. So instead of space between, we're going to have a fixed gap of, let's say, this much. And then we're going to go back to the images, and we're going to add the Flexalon object component to them so that we can fill the remaining space. And we don't need them to be so tall, so we could change the height, something like that. Now we just need to add our icons, and again, those are just more Flexalon layouts. So to each of these images, we can add a Flexalon layout component. Flexible layout component. And then underneath that, we can add a image for the coin icon and some text. Size 100. Change the size of this to 16 and change the image size, say 30. And then we can have it, in this case, we want it left aligned, it looks like. So it is aligning to the left, but the flexible layout itself, it's hard to see in the game view, but you can see in the scene view that the flexible, the image actually, it does look good. So I think I just need to change the gap between these. So add a little bit of a gap and then change the alignment to the start. And again, we need to add a padding to this layout so that things are not butting up right against the edge. So we go back to our parent layout, add a the image layout, add a padding to the Flexalon object left. So that looks pretty good. And then we can duplicate that for our other image. In fact, we'll just duplicate the whole thing and change the image to sword. And you can see here, so this is an interesting bit, which is that the text is falling off the edge. And the reason is because we haven't put any constraints on the size of this text. So even though it's overflowing, by default, largely for backwards compatibility reasons, the size of the children will overflow if they're just too big. And so to fix that, we need to be able to shrink this object so that it can constrain itself to the size of the layout that it's in. So let's add a flexible Flexalon object component to this, and then say that it's, so we can do this one of two ways. We can either say its size is the rest of the layout, in which case it will squish the text to fit its own size, or we can say that this thing needs to shrink to fit within its parent layout. And I'm going to try the second option where I set the width to 0, the minimum width to 0, and that allows it to shrink all the way down to 0 if needed. Okay. So those are the demos I wanted to go over. If you have any questions, feel free to drop them in the chat. I can answer those. There's a couple more points I wanted to go over around how does Flexalon work under the hood? What does the update loop look like? And then how would you write some layouts or adapters that of your own that fit within that framework and can do whatever you need them to do? Okay, so let's go back to our whiteboard and talk a little bit about how does Flexalon work. So at the core of it, you've got this Flexalon singleton. Oops. And you can see that whenever you drop any sort of Flexalon component into the scene, this singleton gets created for you. And this thing has a update loop inside it. It runs on late update. Let's see if I can just show some code here. On late update, it's going to go through the whole scene, check for any root nodes that are dirty, and then go and update them. What are root nodes? So they're basically any game object, the topmost game object that has any sort of layout component on it. So in this case, we've got this flexible layout. This is one root node. We've got this flexible layout, which is another root node. So we've got two root nodes in this scene. So it's going to go and check those guys and ask them, hey, do you need an update? So step 1, it's going to check dirty nodes for update. Now, how did they become dirty in the first place? When you make a change or some change happens at runtime to your scene, most of the changes made to Flexalon layouts, Flexalon object, the parent-child relationships, those are all automatically tracked. You can see this pretty easily if you just go to Flexalon object. Every time you change, for example, the width type in this case, it's going to mark itself as dirty. And what that's going to do is it's going to mark this object as dirty and then work its way up the tree and mark every object up to the root as also dirty. And basically, the reason for that is because if the size of a child changes, it could affect how objects are laid out in the parent layout. It doesn't affect the other children in that layout. It just affects this object and its parents up to the root. So any property changes, I guess step 0. 0. Any property changes, marking some nodes as dirty. Then every frame Flexalon component is going to check, see what is dirty, and go and update those components. And the way it does it is in 2 steps. Step 1, it's going to measure. Well, it's more like 3 steps. Measure, arrange, and I guess apply. So in the measure step, it's going to say, okay, for things that are dirty, what are their sizes? And it does this in multiple passes because sometimes there's a circular dependency between the parent size and the child size. So it's going to do a few passes to kind of suss out what is the size of each layout, what is the size of each child object. And then it's going to go back to those layouts and say, now all the sizes are understood and cached, go and arrange the layouts. And this just does a single pass on every layout that is dirty. It goes in and calls its arrange function to do the actual job. All of this happens in kind of a special space where the layouts don't need to think too much about things like, what if my root is rotated? What if, you know, the user decided to add a scale to things? What if I'm in the middle of an animation? These are done kind of in a space where you're kind of insulated from thinking about all that complicated stuff. You don't need to think about margins and padding because all that is kind of taken care outside of this. It's just, here's the bare minimum information you need to get the job done, to measure the sizes and then arrange the layouts. Then a bunch of transformations happen and we find the final value that we want each object to be at. And we call this apply pass to go through each object that is not already where it needs to be and try to move it towards that position. So this is where we get things like the animators coming in, where the animators might say, I want to just move it 10% towards this target position, or I want to follow a curve, or I want to use physics to push it towards this target position. And so that's done through a transform updater. So looking at this briefly, if you go to the layout interface, this interface, you can see that it needs to call this measure function potentially more than once with this information. Which node are we trying to measure? What size does the user specify that it needs to be? So if the user has said it needs to be component size or fixed size or whatever, what is the size that needs to be? What is the minimum value that the user specified? What is the maximum value the user specified? From this, it kind of comes out with, okay, what are the bounds of the measurement of this object? And then once all the measurements are done, it goes and arranges the object. The layout goes and arranges its children. So if you want to try your own layout, you just need to implement these two methods basically, but that would be really difficult to do by itself. And so there's this base class that implements this interface, and basically you just override the measure and arrange functions, and there's some helpers here for that as well. As an example, there's a custom layout. This custom layout that comes in the samples that shows you how to override, or how to subclass layout base and kind of implement a really comprehensive, I think, layout. You don't always need to do all of these things, but this thing is built so that it shows you how to compute the layout size based on the size of the children if you need it, how to add a gap between them, take that aggregate size and then min-max it between the min and max. And then if there are any children that need to shrink or need to fill their parent, how to apply that. It does all the features. If you don't care for some of those features, like I don't care if the user specifies a min and max, I'm just gonna ignore it. You could just skip this part of it. Or if you think I don't really care if the children are fill size, you don't need to deal with this part of it. If you guarantee that they're always going to be a fixed size. So, and then the range function is actually typically pretty simple. It's just given the objects and their sizes, how are you going to arrange them? What is your algorithm? And then this sample case, it arranges them diagonally stacked. It's kind of like a flexible layout, but diagonal. So that is layouts. And then there's the question, okay, so I've created a custom layout. Let's say this, well, I can open the actual custom layout. So I've created this fancy custom layout here. But let's say now I wanted to size these objects. How are these sizes of these objects determined in the first place? And right now, it's doing whatever the default is that Flexalon decides. So In this case, it's saying I have a mesh renderer component on it, so I'm going to take the size of this sphere mesh. That's going to be the size of this object. And if I were to remove these mesh renderer, now it's instead saying I'm going to use this sphere collider. And as I increase and decrease the collider size, you can see it changes the size. And there's a few different built-in ones. You can take a look at the different ones in the Flexalon adapter file. And so there is this function of like create a default adapter for this thing if one doesn't already exist. So it supports text, it supports images, supports canvas, rect transforms, sprites, meshes, colliders. So if you have something that's not one of those, or you do have one of those, but you actually want it to be sized differently, maybe you have a specific aspect ratio you're going for, or in the example that we saw earlier with the birds, I want to use the texture size of the image that's attached to this mesh instead of just the mesh size. Then you need to add your own custom adapter. And the way to do that is to implement this interface at the top, which is 3 methods. So you want to say, and typically you only need to implement 2 of them. The first one is the really important one is given this requested size by the user and this min and max, how are you going to measure the size of this node? And you can take a look through here. There's some helpers that will help you with that. And then there is how do you, given the size, now you've told us the size of the node, how are you going to modify the transform scale to apply that size? Because not everything needs to change the transform scales. For example, when I change this collider size, you can see that the transform scale isn't changing. But when I had a mesh, the transform scale has to, in this case, I think it does, yes. So instead of changing this radius, it's going to change this transform scale. You can imagine a different adapter that instead of changing the scale, keeps the scale the same, but then changes the radius of the sphere to match whatever the Flexalon object size should be. But in different cases, for example, when we're doing 2D, we don't want to change the scales of things. We want to change typically the rect transform. So that's what this other one is about. Maybe you don't want to change the scale, but you do want to change the rect size based on the measured size of your object. So if you look at the example image adapter, the way it does its work is first it finds the texture that it wants to use as its size. It does that on update. And then given the texture, it implements measure by saying, I'm going to take the size of this texture, pass it to this little helper function that'll maintain aspect ratio. And that's it. It returns that measure size. And then it says, okay, so now that I have the size, I actually want to scale the transform so that the quad is squished to fit that measured size. But it doesn't deal with rect transform, so it just returns false in that case. So hopefully that is a helpful overview of how this works. And so you've got the measure step, which is checking the layout measure and adapter measure. Then the arrange step, which is calling layout.arrange. And then finally, the transform updater is being used in the apply method. There is another piece of the adapter here is used as well, which is the try get scale or get size. So I guess the last piece is the transform updater, which is how animations are implemented. And it's not too complicated of an interface, but it does have to deal with position, rotation to scale, and rect size separately. So basically say, this pre-update is just in case you need to do something before the update, like capture the current world transform or something like that. But then these other methods are the important ones of, okay, Flexalon has computed that this is the final position of the object, this position, and in local space. And you need to then you need to actually change the game object somehow to move towards that position. And similarly, this is the rotation Flexalon has computed. You need to go to that location. And same with scale and rect size. So this is how the lerp animator is implemented. It says, for example, in update position, depending on if you want it to animate in world space or not, let's take the simple case of local space. It's simply computing, it's simply doing a lerp between its current transform position to its desired position set by Flexalon at some interpolation speed. And then the return value here is, are you done or not? And this is a performance optimization because we don't want to keep calling this method forever. When it's actually reached the final position, Flexalon will stop updating this object. Okay, I think that covers most of what I wanted to go over. I thought what might be fun is to do a, well, we could do it another time. I was thinking of doing a Copilot demo. But Copilot is right now in early access and it's free. So if you haven't tried it, I recommend that you give it a shot because it's not going to be free forever. And I really need to have a bit more data to be able to train the model a little bit more so that it is actually good enough for your use cases. So I think we'll end there. Thanks everybody for coming and for listening to me ramble about Flexalon. Be sure to visit the website to see all the latest updates. Show up on the Discord and let us know if you have any issues or questions. All right, bye.